This is going to go over Chapter 23, the digestive system, Objective 4. So previously we mentioned that there were accessory organs of the digestive system that lie outside of the GI tract and bring materials in. Well, these are the four that we're going to be talking about: the liver, the pancreas, and the gallbladder. Salivary glands is not in this one, but that would also be an accessory organ. So let's go ahead and get started. So what are the functions of the liver? Let's talk about the liver first. It's got a lot of functions. So the first one is it manufactures bile salts. So keep in mind, it does manufacture bile, and then it sends it to the gallbladder for storage, right? And the gallbladder, we'll talk about that in a second. Not only does it store the bile, it actually concentrates the bile there too. So what's made in the liver is kind of dilute bile in comparison to what you're getting from the gallbladder. So bile from the liver is also going to enter into the duodenum, that first section. So if you follow that, all these little bile ducts come together and they're going to all converge in this one piece right here. And it will then join with the cystic duct from the gallbladder. And you're going to get bile from the gallbladder along with bile from the liver. And it will be in what's called the common bile duct, and collectively this will go and dump into the first section of the duodenum. Liver cells that produce bile are called hepatocytes. Hepato means liver, cyte means cell. So if you think about it, that kind of makes sense. Another function of the liver, yes, it does make bile. It makes about 600 to 1,000 milliliters a day made by those hepatocytes. The job of the bile is to neutralize and dilute that stomach acid and emulsify those lipids. If you take a look at what's inside of bile, you're going to find bile salt. You're going to find bilirubin, which is an excretory product that is produced during the breakdown of hemoglobin. Hemoglobin is the protein found in red blood cells. So when you look at that, that's why the liver is going to be such a dark red color along with the spleen. It also contains, bile also contains cholesterol, some lipids, some lecithin, and some fat-soluble hormones. So there's a lot going on in bile. Another function, the hepatocytes remove glucose from the blood and store it as glycogen. Now, we talked about this previously back in AP1. Yes, the liver and skeletal muscle cells, if you remember, store glucose in the form of glycogen. So the liver is doing that also. Remember, this is finite energy storage, which means the liver can only store so much glycogen. After that, when its glycogen storage facilities get full, it can't store any more glycogen. Hepatocytes store lipids and vitamins. So they store vitamin K, vitamin A, vitamin D, vitamin E. These are your water-soluble vitamins. I just spell it this way because it reminds me, it spells a word to me, CADE. That's how I remember it. And then vitamin B12. Hepatocytes interconvert nutrients. We're going to talk about that when we get to the nutrition chapter in chapter 24. So it will be able to take triglycerides, for example, and turn it into glucose. It'll take proteins and turn it into glucose and then store it in form of glycogen if necessary. Hepatocytes remove toxins from the blood, such as ammonia, byproducts of amino acid metabolism. We talked about that as a function of the liver back in chapter 1. Number 7, another thing that the liver does is it produces new compounds such as proteins, specifically that are going to go into the blood: albumin, fibrinogen, heparin, clotting factors. Again, talked about that in the blood chapter. We just never said hepatocytes were responsible for that. Now, this one you may not have heard of before. So, Kupffer cells of the liver phagocytize worn-out, dying red blood cells. Now, we know the liver destroys old red blood cells, but it's actually the Kupffer cells of the liver that do that. Not only that, they also take a look at white blood cells and phagocytize those, bacteria, other debris, macrophages. So if it's on the way out the door, the Kupffer cells take care of that and get rid of it. Now, let's take a look at the pancreas. The pancreas secretes pancreatic juice, and if you remember, the pancreas is not only an endocrine gland, it's also an exocrine gland. So the endocrine part, this is going to be those islets of Langerhans, these little purple flowers right here, if you want to think about it that way. They are producing insulin and glucagon. They've got those alpha cells and beta cells and delta cells in there. Now, it also has, your pancreas also has exocrine functions, and these are going to be handled by the Accessory cells or the acinar cells, this group right here. And they're going to secrete these digestive enzymes, which are going to enter into the pancreatic duct, make their way to the first section of the small intestine. Again, here's another kind of grouping here of that exocrine function. The pancreatic juice is then going to go into the first section of the duodenum, or the first section of the small intestine called the duodenum, through that pancreatic duct. So this thicker, in this case brown structure right here, that is that pancreatic duct. So all those acinar cells are going to dump the contents into that pancreatic duct for the exocrine function. All of those digestive enzymes and bicarbonate are then going to go into the small intestine. Bicarbonate neutralizes the acidic chyme that just got dumped in from the stomach. The pancreatic amylase is going to be added to help digest carbohydrates. Trypsin is going to be added to help digest proteins, and pancreatic lipase is going to be added to digest lipids. So the pancreas is going to make sure the small intestine has all of the these digestive enzymes to get chemical digestion started back again. Now the gallbladder, you can see it right here. Again, that green structure. It's going to store 40 to 70 milliliters of bile that was created by the liver. So remember, the liver makes bile, and then it's going to allow it to be stored in the gallbladder. Now, the great thing about the storage of bile in the gallbladder is that it is concentrating it. So the bile in the gallbladder is 5 to 10 times more concentrated than what comes from the liver. So if you've ever heard of somebody who has had their gallbladder removed, one of the problems they have is eating fatty foods. They can't break those fatty foods down. Now, they can eat a little bit, but they can't eat a lot. Why can they eat a little bit if you don't have a gallbladder anymore? Well, that unconcentrated bile from the liver is still coming in and is going into the duodenum. Now, you're not getting the concentrated bile from the liver, so again, you can't eat a lot of fats, but you can eat some fats because you get the unconcentrated bile coming from the liver. Cholecytokinin, created from the small intestine, causes the gallbladder to contract, which dumps large amounts of bile into that small intestine. And that concludes Objective 4.